Welcome to new episode of MemoMap, and today we are going to discuss the vascular biophysics, and we are going to explore first the forces that acting on the blood vessel, then the principle of the blood flow and the vascular compliance, and finally we are going to talk about the Laplace law. So get ready and let's build the map today. First, let's talk about the forces which acts on the blood pressure, and there are three major forces. First, the pressure, and this force acts perpendicular to the wall of the blood vessels, pushing the wall outward. So, it expand or distend the blood vessel. The second force is the tension, and it's called the tensile force. And unlike the blood pressure, the tensile force act circumferential along the wall of blood vessel, and it's mainly due to the molecular attraction within the vascular wall, and it opposes the outward force of the pressures prevent the wall from ruptures. And finally, the charge stress forces, and this is a tangential force, act parallel to the endothelial surfaces generated by the blood flow moving across the endothelium. Shear stress important because it initiates the mechanotransduction. So, all three forces, pressure, perpendicular, tension, circumferential, shear stress, tangential, sensed by the endothelium, and the endothelium transmit this signal to the smooth muscles, affecting the gene expression and the vascular function. Now let's move to the second major concept is the flow dynamics, and here we are going to focus about 4 points. First, the definition of the flow, the law, the velocity, and the type of the flow. Starting with the definition of the flow. The flow is the volume of the fluid that passes through a given point per unit time. The cardiac output is a good example for the flow, since it is the volume of blood pumped by the heart per minute. So, whenever we talk about the systematic flow, we actually focusing on the cardiac output. The law of the flow. Mathematically, the flow depends on the pressure gradient over the resistance. However, the resistance depends on three main factors: the length of the vessel, the blood viscosity, and the vessel radius. More specifically, the resistance is direct proportional to the length and viscosity, while inverse proportion to the force power of the radius. So the Hagen equation stated that pi multiplied by pressure gradient multiplied by power force radius divided 8 multiplied by the viscosity and the length. However, the most important variable here is the radius because it is powerful, and also it is the main factor that the body primary can regulate it to regulate or to maintain the flow. So the constriction causes a dramatic drop in the flow, while the dilatation causes a dramatic increase in the flow. Let's talk about the velocity. The velocity is related to the cross-sectional area, and it is inverse relation to the cross-sectional area. The aorta has a small cross-sectional, so the velocity is high, while the capillary opposite has a large cross-sectional, so the velocity is very low. And the low velocity of the capillary is very important to give a time for the exchange of the nutrients and substances. The type of the flow, the laminar flow, it's a normal physiological flow. It is silent. The blood moves in parallel with the velocity max at the center, and the velocity near the wall is almost zero. Then we have the turbulent flow, which is a regular chaotic movement, and it produces sound like and occur under a normal condition, like the increase the velocity and the decrease of the viscosity, the sudden change in the diameter, sudden change in the direction, and the roughness of the vessel wall. So to remember this, 2V and 2D plus the roughness causing the turbulence. Now let's move to our third concept is the vascular compliance, and here we discuss three main points: the definition, the difference, and when the compliance could decrease. For the definition, the compliance is the ratio between the change in the volume divided by the change in the pressure, and it reflects how easily the blood vessels can expand when the volume is increased. The high compliant vessels means that the vessel accommodates large volume with only small rising in the pressure. Now let's compare the vein and the artery. The vein have much higher compliance than the artery. So let's imagine that the thick wall of the artery is a thick balloon, while the vein is the plastic bag. So, if we add the same volume of blood to the vein and to the artery, in the artery, which is similar to the balloon, the pressure rises significantly. Why? Because the artery has a thick wall, elastic, and high elastic, so the strong tends to recoil, while the vein the pressure change only slightly. Why? Because the vein have a thinner wall and less elastic tissue, so it can stretch easily. So the vein large change in the volume cause a small change in the pressure. This is why it has a high compliance. While in the artery, small change in the volume cause a large change in the pressure, so it has a low compliance. The vein function as a blood reservoir because it has a high compliance. When does the compliance decrease? The compliance can decrease when the vessels become more stiff. This occurs in several situations. So when the vessel is over-distended, cannot be stretched anymore, this causes a decrease in the compliance. When there is increase in sympathetic tone, there is an decrease in the compliance. When there is atherosclerosis and ages, both of them can cause a decrease in the compliance because the wall is become more stiff. So the same blood volume causes a marked rise in the pressures because the vessels no longer expand properly. Now let's talk about the Laplace law. The Laplace law stated that the pressure equal tension over the radius, or the tension equal pressure multiply the radius. So this law is important because it gives an explanation for the why the capillary does not rupture despite the changing in the pressure and exposure to the high pressure, because the radius is extremely small, and since the tension equals the pressure multiply the radius, the small radius resulting in a very low tensions. And regarding this second point is the stress relaxation. It is an important concept for the Laplace law. When the vessel suddenly stretched by increase the volume, the wall tension initially rise. However, if the volume remain constant over time, the tension gradually decrease, and this will decreasing the pressures. So this adaptive mechanism allows the blood vessel to accommodate sustained increasing in the volume without elevating in the blood pressures. With that, we reach to the end of today's MemoMap on the biophysics of blood vessels. Let's recap the big picture. First, we begin with the forces that act on the vessels, which are three forces: the pressure push out, the tension oppose the pressure, and the shear stress act tangentially along the endothelium. And then we talked about the flow dynamic. We discussed definition, the law, the rule of the radius, which is important for the regulation of the flow, and then the difference between the laminar and the turbulent flow. And after that, we discuss the vascular compliance, the definition, and then we compare the compliance of the vein to the artery, and we identify the condition which decreasing the compliances. And finally, we talked about the Laplace law, which is relate the pressure, the tension, and the radiuses. And so Here today we need to memorize three main law: the law for the flow, the law of compliance, and the Laplace law. That's all for today, MemoMap. See you in next episode.